How's it going, YouTube? Don here. In this video, we're going to do number 272, closest binary tree search value. So given the root of a binary search tree, a target value, and an integer k, return the k values in the BST that are closest to the target. You may return the answer in any order. You are guaranteed to have one unique set of k values in the BST that are closest to the target. So if we take a look in this example, we can see that we have a typical BST here, and then we have a target of 3.714286, k is equal to 2. So whenever we see that k is equal to something and then we want to return k values, automatically I think that we're going to be using a heap or a priority queue. But we also have to keep in mind here that we're using a BST, a binary search tree. So we also have to have some sort of a tree traversal algorithm in order to actually traverse it, right? So another thing that we need to consider is that we need to find the closest value. So how do we find the closest value, you might be thinking to yourself? Well, the one thing that I'm thinking right now is, what if we decided to minus each of the root values here from our target here, 1, 4, 2, 8, 6. So if we do that, what we're going to get is 4 minus 3.7 something is going to be, I believe, 1.714286, right? And then let's see number 2 minus 3.714,286 is equal to also 1.714286. all right, so 2 minus 3 is 1.7. 4 minus 3 is actually, this is 0. My bad. Is it? Yeah, it's like 0.28 something. I can't do mental math right now. Let's actually use a calculator. 0.714283 is 0.285. Right? And then we have 3.714286 minus 2 is 1.74. all right, and then what else do we have? We have 5, so 5 minus 3.714286 equals 2 point something. So 2.714 dot dot dot, and then we have 1 minus 3.714286 is equal to, I believe that's 2.7 something dot dot dot, and then lastly we have 3 minus 3.714286. So that's going to be 0.71, right? So as you can see here, what are the values that we would be returning? Well, we would be returning this and this. And as you can see here, that's exactly what we're returning here. So how do we do this? Well, what we want to do is we actually want to use a min heap, taking to this this final value here after we subtract it, and then from there we're just gonna output those values, right? So what do we need to do here? We need to use, one is a DFS, You could also use a BFS, but it doesn't really matter in this case as long as you're using some sort of tree traversal algorithm. And 2, we're going to use a min heap, right? So now that we know that, let's see how we implement that with code here. So the first thing that I want to do is I want to take it one step at a time, right? So what I want to do is I want to create my depth first search, and what we're going to do is we're going to pass in the current node, we're going to pass in the target, and we're going to pass in the heap, right? Because we do want to make sure that we're pushing the values into the heap here, right? So if current node is none, all we need to do is we're going to return, since we don't need to do any type of like traversal, or we don't have any return default value. Then the next thing we're going to do is we're going to simply traverse the tree. So we're just going to keep going down, and then we're going to push the values into the heap as we go along. So I'll show you guys how to do that. So we're going to have DFS current node.left, traverse the left hand side first, target, and then heap. Then what we're going to do is, it doesn't really matter what order you do it, but we're going to do heap push. The first thing I forgot to do is from heap q import heap push heap pop. Alright, so heap push, what we're going to do is we're going to take the absolute value of the current node.val minus the target, right? So this is going to tell us which is the min heap right now, and that's going to help us get our final result, right? Then we're also going to also pass in the current node.val for comparison's sake, just in case we get a really close value. We're going to take the closest actual value, the current node.value, as the comparison, right? So if we had, say, I don't know, can't think of a good example here. Most cases it's going to work, but depending on, let's see, if we had something close, like say 2 point, now I can't think of an example right now, but we always want to pass in another value for comparison's sake. So DFS current node dot right, traverse the right hand side if we can't find anything on the left hand side, just like how a DFS would work. And finally, we're going to create our heap here. We're going to call our DFS root target heap, and then lastly we're going to pop the elements from the heap with our output. If you haven't watched, if you don't really understand what's going on here, I do recommend that you do binary tree in order traversal. I believe I have one on my channel, and closest binary tree value, which I will do in the near future. So output is equal to an empty array, right? And then for blank, since we don't care what's in here, in range of k, what we're going to do is we're going to append our values to the output, heap pop, and what we're going to do is we're going to pop values from the heap and the first element, right? And lastly, we're going to return output, right? And that should work. Heap pop, one element should be in the list. Oh, I'm stupid. Forgot that. Then obviously, in order to prevent it from passing me an error, I want to make it one argument instead of two. And there we go. All right. And all our test cases pass. And success. And we see that's faster than 88.46. Our time complexity here will be O of n log k, depending on if you have k elements, right? So if you guys enjoyed the video, don't forget to hit like, comment, subscribe. Leave me a comment if you're confused about anything, and I'll see you next time.